Hey, we got ourselves the Blue Book app. It's got the practice tests in here, and I've already taken some pictures, and we're going to dive into the very first problem on the very first official practice test for the digital SAT. Let's get started. Which frequency table correctly represents the data listed? Well, let me see here. I've got two 13s. So that means when I see the number 13, I'm looking for a 2 underneath the frequency. Well, how many 8s do I have? Let's see. I got 3. So far that one's looking good. And how many 4s do I have? I have 4 4s. That's it. That's our table right there. You might be suspicious because we didn't even look at the other answer choices, but there's no need to. All right, I'm out of here. Have a good day. We got ourselves number 2 from the official practice test. Number 1 on the Blue Book app. Which expression is equivalent to x squared plus 3x minus 40? Well, we got ourselves a lot of these double bubbles going on. But the key to double bubble is that you need two numbers that multiply together to get you that last number, but they gotta add together to get you the middle. So I'm gonna start by thinking about two numbers that multiply to negative 40, and then I'm gonna pray that they add to 3. Well, you know what? I got the answer choices here, so let's be lazy. Negative 4 times 10. Does that multiply to negative 40? Sure does. Okay, but if I add them together, getting 6, not 3. Okay, that one's out of here. Let's try the next one. Let's see, we got ourselves negative 5 and 8. Negative 5 times 8 multiplies to negative 40, but does it add to what we want? It sure does! So that's it, we're done! We got our first word problem on the new SAT practice test. I'm scared. Jay walks at a speed of 3 miles per hour and runs at a speed of 5 miles per hour. He walks for W hours. Okay, you know what? My spider sense is telling me it's time for some underlining. He walks for 3 miles per hour and he walks for W hours. Okay. And he's running at a speed of 5 miles per hour, but then he runs for R hours, and it comes out to a total of 14 miles. Which equation represents the situation? Well, let's see. Total of 14. That means two things you're probably going to add together to get me 14. So I got my eye on these two answers. And then if I look at that first one, it's 3 times W. Let me think about that for a second. The 3 is measured in miles per hour. The W is, okay, let's see, what did they say here? W is the amount of hours. Okay, so I got hours. The other one was miles per hour. So if I just focus on the units right now, miles per hour times hour, that would cancel out the hour unit, leaving me with just miles. So I could say I have 3W miles. So that seems pretty good. If I try doing a similar analysis for B, I've got 1 over 3 times W. Well, if I analyze the units on that one, W was measured in hours. The 3 was measured in miles per hour. Okay, this is not exactly working out the way I want. In fact, my units, if all I focus on are the units, then it would be hours over miles per hour. So that would be like I'd have to keep change flip there and switch the bottom to hours over hours squared over miles. What would I use that for? That doesn't make any sense. But the other one was coming out to miles. so a certain amount of miles for the 3W. Well, by a similar logic, the 5R would also be measured in miles. So basically, I would have some miles, add on some more miles, and what's the 14 measured in? Oh, that's right, miles. Unit analysis, sometimes called dimensional analysis if you want to get tricky, but unit analysis can be super helpful when you're trying to figure out which one of those choices makes sense. All right, that's it. I'm out of here. Oh no, a triangle. I hate geometry, but I hate it less when there's a picture for it. So let's make ourselves a little triangle here. It's triangle A, B, C. Measure of angle B is 52. Measure of angle C is 17. And they want to know the measure of angle A. Well, turns out whenever you add the three angles of a triangle, you always get 180. Therefore, we need to add 17 and 52. That gets us 69. Add that to question mark to get 180. And now all we have to do is subtract the 69 from 180. And that gets us 111. We got ourselves another word problem. The graph represents the total charge in dollars by an electrician for X hours of work. The electrician charges a one-time fee plus an hourly rate. What is the best interpretation of the slope of the graph? Is it going to be his hourly rate? Is it going to be his one-time fee? Blah, 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 blah. Well, let's try throwing some numbers in that might make sense. Let's say that this electrician, he charges an hourly rate of, let's give it $100 an hour. But we also got to have a one-time fee. God forbid the job's only 5 minutes. He doesn't want to be charging for only 5 minutes of his time. It's going to be very little amount of money. So maybe he's got, maybe a $50 one-time fee. Okay, so then if we wanted to write an equation for how much he's be charging us, it's going to be $50 plus 100 for each hour. So what that means is it's going to be 100 times the number of hours. Well, how many hours is he working? They told us. They said X hours. So that means we're going to have to multiply the 100 by X. Okay. And that would get us the total charge. So I'll put T for total. So basically our equation is T equals 50 plus 100x. Okay. And now they want to know about the slope. That's the question. Well, the thing I just came up with looks a lot like mx plus b, where m is always the slope. So in our case, that would be 100. But what was 100? 100 was his hourly rate. That's it. That's all you got to do. That means I'm not going to talk about this problem. I'm just going to end the video. Not going to talk about the problem anymore. Just going to end the video. All right, a tile problem. Let's go straight to the question because we got ourselves a table here. Let's just go straight to the question. Maybe we'll be able to figure it out without reading everything else. If one of these tiles is selected at random, what is the probability of selecting a red tile? Let's see, red. Different types of red. Maybe a square red tile, maybe a pentagon red tile. But what's the probability of selecting a red tile? Well, looks like we've got 10 plus 20. That adds up to 30 red tiles. But how many tiles do we have in total? Well, they tell us in 3 different kinds of ways that we've got a total of 100. Over here, they also use the word total, and there's 100. So all you got to do here is figure out how many red tiles there are and divide it by the total. And the total is 100, so really all you have to do is just 30 over 100. Express your answer as a decimal or a fraction. Okay, well, 30 over 100, I'm not sure if that's going to fit in the answer choice space that I'm given, so let's just cross out these zeros and call it 3 over 10. Sounds good. Take care. Goodbye. Yo! We got to figure out which of the following is a plausible value for the total number of people in the population who support the proposed legislation. Support being kind of the key word there. And I see that there was some sort of survey where some people supported it. Well, how many people? It says 35% of people in the population. Let's see, where do I see the word population? 50,000 people. So when they say 35% of people in the population, they could have just said 35% of 50,000. Okay, so if I go to a calculator and I type in 0.35 times 50,000, I get 17,500. And out of all these answer choices, only C looks like it's kind of close. Now, the reason why it's not the same number is because they said there's a margin of error of 3%. So that actually means you could be plus or minus 3% or somewhere in that range. So you could be between 32% or as high as 38%. So if we were to go down to 32%, we'd actually get down to 16,000, which is even lower than our answer. But our answer would fall within the right range. So that's it. Answer C. Have a good day. No answer choices in this one. You got to actually know something. All right. Well, maybe you don't. Because you know what? On the new SAT, you are allowed to use Desmos. So if you want to be one of those kids, you can easily do so. All you got to do is type in the equation. Now, is the final version of the SAT going to allow it to be this easy to the point where it just puts a line through what the answer is? I don't know. But let's say you want to actually figure out how to do this by hand. If they get rid of the fact that you can just type in the equation and it just shows the answer, then you might at least need to know a little bit better how to use Desmos. And one way to do that would be by typing in the left side, and then by going to the next line, typing in the other side, zooming out a little bit until you see an answer. And getting the X would be your answer in this case. Even though I know the Y happens to be the same in this case. Okay, that will not get taken out. So therefore, if you want to do it by graphing, go for it. Now, if you are still curious as to how you would do this without graphing, you could put this 1 over 1 and then you could cross multiply. So that means you get 55 equals x times x plus 6. That's the same thing as saying x squared plus 6x. If I now subtract the 55 from both sides, this side would turn into a 0. I then would have to factor this, and this is going to factor into x plus 11, x minus 5, and that means x will equal negative 11 or 5, but they were only looking for the positive solution. So it turns out the answer is 5. Now, by the way, I didn't mention that when you're looking at the graph, there also should be another solution. And indeed, if I zoom out, there's another one at negative 11. But remember, they asked for the positive solution. So no matter what way you do it, You got to only use the positive answer, and once again, that positive answer was 5. All right, take care. All right, we got ourselves an airplane that starts at 9,500 feet in the sky, and then it eventually makes it down to 5,000, but it's descending at a constant rate of 400 feet per minute. And they want to know what type of function best models the relationship between the descending airplane's altitude and time. Well, we either have to go with decreasing exponential, decreasing linear, or the increasing versions. But it definitely ain't increasing. The altitude ain't increasing. So is it decreasing linear or is it decreasing exponential? Well, if you've got yourself a constant rate, then that means you will be able to put it into the form of mx plus b. In this case, instead of writing something like y equals mx plus b, I could write 9,500 minus 400t, where t will represent the number of minutes that I've waited. So if I can write it like that, and I say that the altitude is equal to 9,500 minus 400t, then it's kind of matching up with mx plus b. I could say that the m is negative 400, and I can use t instead of x, and then I can identify that this would be my b, but I didn't really need to mention all those little details. The main thing that you need to know is that mx plus b is the equation of a line. So it's decreasing linear. If it's going down by the same amount each minute, that's always going to be linear. All right, I'm out of here. Y-intercept, my favorite. How do you figure out a y-intercept of a graph? Well, if you're ever on the y-axis, we call that point a y-intercept. But whenever you're on the y-axis, your x will always be 0. So when you have a y-intercept, it's always true that your x will equal 0. That's the key. By the way, in case you ever are asked for a x-intercept, your y will be 0. Kind of vice versa thing going on over there. So anyway, the thing we need to focus on is just simply y-intercept means x equals 0. So, all right, let's take our equation and then let's throw in a 0 for the x. So let's just copy that equation one more time, but wherever we see a x, we are now putting 0. So I'm putting 0 where I see this x as well. Doesn't really matter, that's just a notation thing. But most important side is this side where you have something raised to the 0. Well, if you go into your calculator, you will find out that something raised to the 0 is 1. So that means I now have 11 times 1, which is 11. And because that is equal to g of 0, and g of x means y, that means 11 should be my y. You probably already knew that 5 seconds ago. All right, I'm getting out of here. Bye-bye. Geometry, circles. What do these two words have to do with one another? Let's find out. The circle has center O, circumference 144 pi. That means the length all the way around is 144 pi. Then what are they asking for? They're asking for the length of arc QR. That would be here, just a piece of that. Okay, Then they also told me that we've got some diameters. All right, seems obvious. There's an O in the middle. That's what they usually do for centers. Anyway, next thing that they tell me is that the length of arc PS is twice the length of arc PQ. So let's say I called PQ X, then the length of arc PS, well, if that's twice that, then that would be 2x. So I can put a 2x right there. Huh. Well, it looks like we've got some symmetry here. So if I had to take a good guess, I would say that this thing that they're asking about is also 2x. Indeed, that ends up being true. And right above here, it looks like that should be x as well. And now if I were to travel around this circle, 2x plus x plus 2x plus x, that would get me, let's see, I guess 6 x's. And that should equal what we said the circumference was, the 144 pi. So I'm looking for the 2x one. So if I want to be super cool here, if I want to get from 6x to 2x, well, I could just divide by 3. And if I do 144 divided by 3, I'm going to say that's going to be 48. So 48 pi is the answer. All right, we're done. They gave us a rectangle problem without giving us a picture of a rectangle. Let's fix that. Here we go. Now they said they want the area. Area of a rectangle, length times width. What is the length? The length is x. What is the width? The width is x minus 15. I must put that in parentheses if I'm going to multiply it by my length. But not only that, they also told us what the area is. They told us it's 76. So what use was my picture for the rectangle? No use. Let's get rid of it. Didn't even need it. Such a simple problem. Area equals length times width. As long as you know that, you just plug in everything. Now it's time to solve. Well, how do I solve this? I can distribute my x over here. That'll get me x squared minus 15x. Also, I want to get 0 on this side. So that means I'm going to need to subtract 76. So I'll end up with a minus 76 right there. Okay, but now I need to factor this. Ew, gross. 76, such a big number. I don't even want to do it. This stinks. How about I just use my Desmos? X squared minus 15x minus 76. And I want to know where it equals 0, so that means I just take a peek on the x-axis. And you might notice -4. Wait a second, that wouldn't have made any sense if we would have had a rectangle. -4 can't be the length, so only 19 makes sense. It's also the only answer in the answer choice. All right, take care. We got ourselves some table, words, and answer choices. And it turns out we don't need the words. We just need to match up the table with the choices. So one way to do this is just go to Desmos and just type in those answer choices. I already typed in the first one. And then you hit the gear and you go to the table button. Then it's going to automatically create a table for you. And actually, if I would have done this with X and I didn't even put anything there, then it's actually going to create a table automatically with the numbers already filled in. And we can see that we're looking for 0, 1, and 2. But those numbers are definitely not matching up with what the table is. So answer is definitely not A. Okay, so now I go here and I'm going to type B. So I'll put 1 plus, what is it, 0.004. And that's raised to the x. Now, is that getting me the numbers that I want? No. 0 is supposed to go at 604. Okay, so let's try C. And C, it's almost like the same thing, except there's supposed to be a 604 in the front. Is that getting me what I want? Huh. That one kind of looks like it's doing the trick. We just got to pay a little bit careful attention to these numbers. Let's just analyze this a little bit better. So here are our numbers. And let's see, 0, 604. So far, so good. 1, 606.42. Well, that's actually what this would round to. So that's looking pretty good. And then 2, blah, blah, blah. Okay, looks like my answer C. Now, because I had to round, I really should just ask myself, could it possibly be D? But if you try plugging in the easiest number, which would be 0, anything raised to the 0 is always 1. So that means that this would come out to 1. Then you'd have times 0.004. And that's coming out to 0.004. That's not what we want it to come out to. So no, the answer is definitely not D. It is C. And that's how you use Desmos. Create a table and match it up. You could also plug it in by hand if you're super good. So that's it. We're done. Let's get out of here. All right, the SAT is officially making me very angry for including a lot of questions that are ridiculously easy to do on Desmos. At how many points do the graphs of the equations intersect in the xy plane? Gee, that's so difficult! How many more points is a red token worth than a green token? At a school fair, students can win colored tokens that are worth a different number of points depending on the color. One student won G green tokens and R red tokens, and it was worth a total of 380 points. A given equation represents a situation. Well, we're going to start by taking that equation, and we're going to notice that it's got equals 380. That's the total number of points. So that's the unit that the total is in. But on the left side, I've got something plus something else. Well, the only way that everything can work out is if this also has the same units. If this is also in terms of points. But we already know that G is supposed to have a certain unit. It's supposed to have a unit of tokens. So G itself on its own is measured in tokens. But because it's supposed to come out to a unit of points, that must mean that the 5 is got to have a unit of points per token. And that way, the token unit would cancel. I would get points. But you might have been able to figure this out without having to do all this little work about the units. You might have been able to say, oh, so a green token is just 5 points then, right? And a red token is 45 points. So how many more points is a red token worth than a green token? 40. And that's it. We are done. Welcome back. We got some more words in our problem. which represents the number of bacteria Y in the liquid medium T days after the start of the observation. Okay, well, now I gotta read the first sentence. Number of bacteria in a liquid medium doubles every day. Doubles every day. Okay, there are 44,000 at the start. All right, let's organize that information. So at the start, we got 44,000. And then it's going to double every day. So double 44,000 would be whatever 44,000 times 2 is. Now, that's after 1 day. But what they're saying is that T is going to be the number of days after the start. So that would mean after 1 day, T would equal 1. But also, at the start, that would mean T would equal, wait a second, how many days after the start? 0! So that means when T is equal to 0, Y, which is the number of bacteria, should equal 44,000. So let me just write that down for y'all. When T is equal to 0, Y is equal to 44,000. Also, when we look at the other guy, when T is equal to 1, Y should be 44,000 times 2. Okay, so that's basically our key here. So let's get started with plugging in 0 for T and praying we get 44,000. Okay, well, if I take a look at the first guy and I plug in 0 there, I gotta know what happens when I raise something to the 0. Well, it turns out it's 1. So that means you get 1/2 times 1. Uh-oh. 1/2 times 1 is 1/2. That's not 44,000, is it? I don't think so. So that one's gone. Now, if I were to plug in 0 over here, again, this is 1. So 2 times 1, that just gets me 2. Not what I'm looking for. 44,000 times 1. Okay, that's working. This one would also be 1, though. Okay, so we've narrowed it down to C and D. But now we got to go down to the fact that when T equals 1, we're supposed to get 44,000 times 2. So when I plug in the 1 in C, I get 22,000. Not what I'm looking for. This one is 44 times 2. That gets me what I'm looking for. Answer is D. You know, this is the slow way of doing it. You might have noticed right off the bat that we are multiplying by 2 to the 1 if we just plug in the 1. So plugging in the 1 at the very beginning could be helpful. But also just recognizing that if I were to have continued this process when T equals 2, then it should have been 44,000 times 2, but times another 2. And 2 times 2, I'm pretty sure that's 2 to the 2. In fact, if I would have done it one more time, there would have been a 2 times 2 times 2 at the end, and that would have been 2 to the 3. If I want to get general about that, it's 2 to the T. So if you see another doubling problem, you just go after the one that has the 2 to the T. I'm out of here. Have a nice day. We got ourselves a volume problem. That's what they want to know. Well, let's go take a glance at the reference sheet, and we're looking for the volume of a cylinder. And that's right here, volume of a cylinder. It is pi r squared h. Well, they gave me the h, so I can plug that in. Did they give me the r? No, they gave me d. Well, if d is equal to 8, that means r is equal to 4. So we got 4 squared pi blah blah blah. 4 squared, I think that's 16. 16 times 12 times the pi. The only thing that would make sense here would be 192. No need for a calculator. All right, have some fun. If you like fast solutions to system of equations, you're going to love this problem. Type in both of these equations into Desmos, do the little clicky thing, and recognize what the y value is. I'm out of here. Hey, looks like a problem that we can't immediately use Desmos for. So we actually have to draw a diagram. They told us that we got triangle JKL, but can't put J where I just put it because they said J is a right angle. So J goes over here, then K, then L. And they told us that the cosine of K is equal to 24 over 51. Well, what does SOHCAHTOA say? She says that if you have a cosine, you got yourself a k. And what does the k tell you? Well, it tells you that the cosine of whatever your angle is equal to the adjacent over the hypotenuse. So what we could do is let our adjacent be 24 and our hypotenuse be 51. Now, what is a hypotenuse? A hypotenuse is a side that is across from the right angle. So that means our hypotenuse will go right here. And in this case, I'm going to let it be 51. But what about an adjacent? Well, what does that mean? It means adjacent to whatever angle you have. So in this case, we're talking about angle K. And what side is adjacent to that? Well, adjacent means next to. So should I just go with this one? Well, no, because when we say adjacent, we mean the side that's adjacent, but not the hypotenuse. So it's actually this other one that is also next to it. So a little weird, we got two sides that are next to angle K, but the one that we call the adjacent is just the one that's not the hypotenuse. Okay, so anyway, the adjacent in this case, we're going to let that be 24. And now what are they asking for? Well, they're asking for cosine of L. Okay, well, that means it's still going to be adjacent over hypotenuse. And the hypotenuse is not going to change. The hypotenuse is always the hypotenuse, no matter what angle you have here. But the adjacent is not always the same. In this case, when we say adjacent, we mean adjacent to L. And where I see L, the side that's adjacent to that would be here. So this would be my new adjacent. So let's get rid of that one being the adjacent. That side's still 24, but it's not the adjacent anymore. Now, when we say adjacent, we mean adjacent to L. So I'd need to figure out what this one is. Okay, well, let me just call that one X for now. And then I could do a little Pythagorean theorem. And that'll help me figure out what X is. Now, if I want to get the answer for X pretty quick, I can just go to Desmos and type that in. And before the digital SAT, you could not get away with something this slick. But you can actually just type in the equation. And then wherever this thing lands, that's your answer. So that means X has to be 45. Now that you know X is 45, that's the adjacent, and that's what needs to go over the 51. So the answer here is 45 over 51. All right. Hope that was helpful. Take care. I used to do a lot of teaching of how to do stuff like this by hand, but you got Desmos in the digital SAT, so you know the drill. Type in the equation, and in this case, they want to know for what value of X does f of X reach its minimum? Well, f of X is just the Y value, and we're looking for the minimum Y value, which is negative 30, but they're saying for what value of X does that happen? So the negative 30 happens at 6.25. And that's it. That's your answer. You're done. Desmos to the rescue again. We got line L passes through the point 0, 0 and is parallel to the line represented blah, 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 blah. Well, let's start getting a sketch of that. So I'm going to put 0, 0. Let's hit the label button. Then I'm going to do y equals 8x plus 2. And I can see if I zoom in that that does not go through that point. But let's take a picture of what's going on right now and try to figure out how to make sense of what they're talking about. They said in the xy plane, line L passes through the point 0, 0 and is parallel to this other one. So the one I have in green is the y equals 8x plus 2. But there's some other line that is not graphed right now. It's not here, but it's got to be parallel to the green one. And it also has to go through the point 0, 0. Well, if I have to do that, then okay, let's make it parallel and go through the point. Okay, there we go. It is going to look something like that. Now, if I want the equation for that guy, it should also be in y equals mx plus b form. And the thing I have to know is that when lines are parallel, they're going to share the same slope. And the slope is the number in front of the x. It's the m. So that means I know that the slope of the other guy is going to have to be 8. So it's going to be 8x plus whatever the y-intercept is. And the y-intercept, well, where does it go through the y-axis? It goes through at 0. So that's my b. Okay, so now 8x plus 0, that's the same thing as just saying y equals 8x. And now what that line is line L. So line L is the one that goes through point 0, 0. Now that's important because they said if line L also passes through the point 3 comma D, so they're talking about line L, so they're talking about this equation. But they're saying it goes through the point 3 comma D. Okay, well 3D, that is in x comma y form. So that means where I see the x, I should put a 3, and where I see the y, I should put a d. So it's going to be d equals 8 times 3. When 8 is next to the x, it means times. So now we have 8 times 3, which is 24. That's what they wanted to know. They wanted to know the value of d, so we are done. All right, we got ourselves the last one from the first section. You might have thought all this stuff is easy, so stay tuned. We got ourselves the hard section coming up. That's if you do well on the first section, you'll get the hard section. Anyway, last problem here. And they are talking about a line. They're talking about parabolas. And they're saying that they intersected exactly 1 point. Okay, so if the parabola has that equation, what is the value of c? Okay, so first thing I'm going to do is just go to Desmos, get an idea of what's going on here. I got myself a parabola. Okay, but then they're talking about a line that intersects that parabola at exactly 1 point. But one of the things I notice about this line is that if I solve it for y, I get y equals just some constant. Okay, but whenever you get something that is y equals some constant, let's say it was y equals 5, then that would be a horizontal line. Okay, so now that I know that, let's just take a pic of what's going on with this guy. And let's think about how I would get a horizontal line to intersect this parabola at exactly 1 point. Would it be like this? Hell no, that's 2 points. Would it be like, yeah, that would be it. so it needs to touch the tippy top. Well, it would be real nice if I knew the coordinates of the tippy top. Turns out it is blah, 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 blah. Okay, so now that I've got that, I know that my horizontal line has got to come crashing through like that. And if it's going to come crashing through something that has a y coordinate of 10 point blah, 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 then it's going to be y equals 10 point blah, blah, blah. And if you want to confirm that, you probably think, you know, what does this guy know? He doesn't know anything. He's not better than me. Well, there you go. There's proof. It actually is going through that point. Okay, so now that we know it's supposed to be y equals that, well, we got to match that up with the equation that we got that was also in y equals form. So because they're both equal to y, that means I can set these two things equal to each other. So that means c over 2 equals 10 point blah, blah, blah. And now I want to multiply by 2 here, and that'll get me 20.25. And we have completed the first section. Congratulations if you made it through all of these. I will see you in the hard section. See you soon. All right, we're in the hard section of the second section of the first practice test. Let's go. I see some like terms. 9x squared, 7x squared, they both end in x squared. Those are going to add up to 16x squared. And that's all I got to do. The plus 9x, that stays. Can't do anything else with this. Now I'm done with the first problem. Of 900,000 beads, 828,000 are silver. So what percentage of the beads are silver? So that means we're just going to have to put in a fraction of 828,000 divided by 900,000. Well, that's the same thing as just saying 828 divided by 900. And that gets me 0.92. What is 0.92 as a percentage? It's 92%. All right, we're done. Wow, we got ourselves a hard problem here. I definitely won't be able to use Desmos to solve this because the people that made this test made it super hard. Oh, look, solving the equation with Desmos is not working unless we change those t's to x's. And it does solve the, well, where's the solution? Zoom out and you will find it. It's 20. Okay, so what does that mean? That means x would be 20, but remember I was using x instead of t, so t would be 20. Is that the answer to the problem? No, because they asked for 3t, so that's going to be 3 times 20. In other words, 60. In other words, we're done. Some of y'all watching this is probably thinking, yeah, I could use Desmos for this, but can you please show me how to do this without Desmos? Well, sure I can. They're asking for the value of x plus 4. Where do I see x plus 4? Oh, it's actually in the problem. So, you know what I could do? I could call x plus 4 u, and that means I would now have an equation that would read as 5u equals 4u plus 29. I know how to solve that. I'm just going to have to subtract 4u from both sides. That cancels. And I get u equals 29. Well, what were they asking me for? What is the value of u? Which is 29. So we're done. Look at this, a problem I can't use Desmos for. We got ourselves a neighborhood that consists of a 2-hectare park and a 35-hectare residential area. What the hell is a hectare? It's kind of like an acre. Anyway, the total number of trees in the neighborhood is 34. The equation 2x plus blah, 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 blah represents the situation, which is found is the best interpretation of x in this context. Well, let's see who the x is buddies with. He's buddies with the 2. Well, where did I see 2? That was a 2-hectare park. Okay, The Y is buddies with the 35. 35 is for the residential area. All right, now let's read our answer choices. Average number of trees per hectare in the park. Maybe. Average number of trees per hectare in the residential area. Doubtful, because that's what the 35 is for. It's about the residential area. The 2, it's about the park. And what about total number of trees in the park? Of course not. The total number of trees in the park is 39 and 34. Do they think I'm stupid? No, it's not that. Total number of trees in the residential area. Well, that's maybe the only other one that we might have to think about. So, average number of trees per hectare in the park versus total number of trees in residential area. Oh my God, I didn't even have to think. I didn't miss that. It said residential, but we're only supposed to be talking about the park. What is this test? And why is it so easy? Wow, for this problem, there wasn't a drawing of a rectangle. But now there is. For a certain rectangular region, the ratio of its length to its width is 35 to 10. Now, if I want to write that in symbols, I would write L over W equals 35 over 10. If the width of the rectangle increases by 7 units, okay, so whatever W was, it's now going to be W plus 7. We want to know how the length would have to change to maintain the ratio. Okay, so it's either going to increase or decrease. I mean, let's think about it. I guess it's going to have to increase too. So doesn't sound like it's going to be a decrease. Okay, so we got rid of those. Now, how is it going to increase? Is it going to increase by 24.5 or by 7? Well, if I just put 7, would that keep the same ratio? I don't think so. That would kind of change it. So instead, I guess it's going to have to be the only other number they gave me. So it's going to have to increase by 24.5. Now, that's a little tricky to confirm. We've got our best guess here, but we really kind of should think about how we would confirm this. Well, I'll tell you how we're going to confirm it. We're going to remember that the original equation that they gave us is L over W equals 35 over 10. And then if we modify that a little bit to make the change about the width, and we want to maintain the ratio, that means we want the ratio to still stay 35 over 10, then what needs to happen to the length? Well, what needs to happen to the length is it needs to add by a certain amount, and I'm going to call that amount that it needs to add X. So we're going to try to solve for what X is, and let's hope it comes out to 24.5. Otherwise, I'm going to be embarrassed. Okay, so how would we confirm it? Well, if L over W is 35 over 10, where I see the 35 over 10 here, I could replace that with L over W. So then I keep everything else the way it was over here. L plus X over W plus 7 equals L over W. Now I could cross multiply. If I cross multiply, I'll get WL plus XW equals WL plus 7L. But I see a WL on both sides, so goodbye, see you later. And now I've got XW equals 7L. But I'm really after X, so I need to divide by W so I can just get X on its own. And the answer is 7L over W. Well, we said it's supposed to be 24.5, but we're seeing L over W pop up one more time. So what we have to do is replace this L over W with the 35 over 10 And now we've got times 7. So now 7 times 35 over 10. Well, what would that come out to? Let's just ask Desmos. Excuse me, sir. What is 7 times 35 over 10? The answer is 24.5. All right, so that confirmed it. But again, we were able to use our common sense to say, you know what? If the length is bigger than the width, they're not going to increase by the same amount and maintain their ratio. That's not going to happen. It must be whatever the other number is. All right, I'm done with this one. I'll see you later. Another problem that you can't just throw into Desmos so easily. So what are we doing here? Well, it looks pretty clear in the answer choices. They want us to get n equals. In other words, solve for m. In other words, express n in terms of p. Well, what does in terms of p mean? It just means you're going to have p floating around in your answer somewhere. Okay, so basically solve this for n. Let's take the equation and let's try to figure out what n is. Well, n is over here. Oh boy, how am I going to get everything else that's not n away? How am I going to get n equals on its own? Well, how about we start by at least getting rid of that 9. That's easy enough. We got p minus 9 equals 14 over n. Ay, 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 the n is still on the bottom. What am I going to do? Well, you know what? Wouldn't it be nice if I just threw it up to the top and then put the 14 on the bottom and called the whole damn thing n over 14? Well, I can only do that if I take the reciprocal. What? The other side's not a fraction. Well, let's fix that. P minus 9 over 1. Okay, now it's a fraction, so we're going to put 1 over P minus 9. So we took the reciprocal of both sides. Now the n is on the top. Not so confusing anymore. Last thing that's holding me back from getting n on as its own is this darn 14. Now, what's that 14 doing? He's dividing by 14. How do we cancel out a divide by 14? Oh, that's right. We multiply by 14. So we put times 14 on both sides. See you later, 14. Now we got 14 times 1 over P minus 9. And I don't have to tell you that the answer is D. The expression blah, blah, blah is equivalent to blah, 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 blah. Where b is a constant and x is greater than 0, what is the value of b? Let's see. I think I can divide this by 6, and I could even divide these by 6 as well. As long as I can divide everything by 6, then I'm allowed to do it. So that's going to be 4 over x plus 7. Well, if that's equal to 4 over x plus b, I could now just match up here and get the hell out of here. Goodbye! Turns out in this problem, I have to be aware of the form that these equations are in. They're in the form x minus h squared plus y minus k squared equals r squared, where the center has coordinates hk and the radius is equal to r. Okay, so now that I know that, it says the radius of circle B is 2 times the radius of circle A. I'm going to need to know that information in a second. And then it says the equation blah, blah, blah for circle B is this. And what is the value of K? Okay, so we have to figure out what this guy is. Now, this entire equation is for circle B. And this entire equation is for circle A. And now I gotta focus on what they told me about the radius is 2 times the radius of circle A. So let me try to figure out what the radius of circle A is on its own first. Well, let's match up with our formula where the r squared is, here I see a 4. So that means r squared equals 4. Well, you know what? R would have to be 2. Okay, so we finally figured out what the radius of circle A is. It's 2. So if the radius of circle B is 2 times that, then that means that the radius for B is 4. Okay, so now I got the radius of B. However, the answer is not 4. We need to focus on the equation they gave me for B, and also remember that the thing on the right side is supposed to equal r squared. But I just said that the r for B is 4. So that means I'm going to replace this r with 4. So that means 4 squared equals k, which means k is not 4, it's 16. That is the answer. Goodbye, everybody. Goodbye. All right, we got a business owner that's planning to buy chairs for his 81 employees, and it's going to be the same model. So this company sucks, but anyway, he's got a total budget of $14,000, which includes the 7% that the government is going to tack on to the price of the chairs. So if he just went to Staples and said, give me $14,000 worth of chairs, then what they would do is they would say, okay, but the government said we're going to have to multiply that by 1.07 because that's 107% of whatever you're spending. So he wouldn't actually be able to get away with doing 14,000 because it would bring him above 14,000, whatever it comes out to, 15,000 something, I don't know. But anyway, what we need to do is say he can do 1.07 times some number, and then it will come out to 14,000. So what I want to do is go to Desmos and type in 14,000 divided by 1.07. So that's the real total that he can spend, but they don't want to know that. They want to know the maximum he can spend per chair. So that means I need to divide that by my 81. So let's divide this by 81. I got a big ass fraction bar right there. So that puts us at 161.53. I'm done. Hey, looky here, a problem that can be done super easily on Desmos. This is what is considered a complete waste of time. I don't know why they keep doing this. This is extremely infuriating to spend so much time doing something so simple. Now, they intersect at the point 11, negative 99, and that means that a possible value of x would be 11, but we don't see that there, right? So if you fall for the trap, you're going to do negative 11, right? But let's zoom out and let's see if there's another place that they intersect. Oh, they intersect here, so the other possible value of x is negative 15. All right, we're done. If you came looking for a solution to problem 12, you came to the right place. How many solutions does this equation have? I'm going to show y'all a trick. I ain't going to keep doing all this Desmos mumbo jumbo. What I'm going to do is distribute. I get 150x minus 90. On the right side, when I distribute, I get minus 90 plus 150x. Oh my God, that looks so similar to the left side. And you'd be right. In fact, it's more than similar. It's equal. If you ever have two things that are exactly the same on the left side and the right side, that means you have yourself infinite overlap, infinite solutions. We are now done with the problem. In keeping with the trying not to use Desmos when we don't have to strategy, let's do a sketch for this guy. They told me the vertex of my parabola is -3, 6. So let's say that this is -3 and this is 6. Then there we go. That's my vertex. But they're telling us that it's also got an x-intercept of -17/4, 0. Now that's the same thing as saying -4 1/4, 0. So -4 1/4, I guess that might be somewhere around here. I'll just call it -4 1/4. And now they want to know where the other x-intercept of the graph would be. Well, the most important thing to do here is just to focus on the part that we actually need. And that would mean that we can kind of sketch out what's going on here. And I guess that other x-intercept would land somewhere around there. Now, in order to be exact about it, well, it turns out it has to be the same distance that the other x-intercept is from the x-coordinate of the vertex. So there just has to be this symmetry. I'm using lots of words, but you can just focus on the picture here, and it goes over a distance of 1 1/4. So that means over here it must go over a distance of 1 1/4. And if I take -3 and I add 1 1/4, well, let's see, what would that get me to? -1 3/4, which is the same thing as -7/4, and we are done with having to use the word fourth because we figured out the answer, and now we're ending the video. So we are given a graph here, not of f of x, but of f of x plus 14. If y'all thought this was the graph of f of x, y'all just got played. It ain't it, because it's the graph of f of x plus 14. But they're asking for what the graph of f of x would be. Well, if this is the graph of f of x plus 14, that means it got shifted up by 14. So how would we get the graph of the original? We'd have to go down by 14, which would bring us down to a y-intercept, not of 2, but of -12. And that's really all you need to do here. Have a good day. All right, we got ourselves a quadratic that's equal to 0, and they're saying for which of the following values of b will the equation have more than one real solution? Well, when you want to have something equaling 0, then if you happen to have a parabola, that would mean you're dealing with the x-intercepts, because if this was originally y equals that and then the y is 0, well, that means you're on the x-axis. So what we're going to do is go into Desmos and check out where we're going to get more than one real solution. In other words, more than one x-intercept. So I already plugged in the option of D, where we just use a 40 for B. And I can see that my parabola looks pretty janky. It's not crossing that x-intercept. So it's not crossing the x-axis, so it doesn't have an x-intercept. Okay, so then we'll try putting a 5 instead of 40. And okay, still a little bit too much jank. And now we're going to put a -80, and we're going to zoom in, and we can see, oh, okay, it looks like there's just one x-intercept. So y'all already know what the answer is, but everybody wants to see it. Look at that, 2 x-intercepts. That's our dude right there. We're done. Let's see, is it finally getting harder? Maybe. The graph of blah, blah, blah has an x-intercept at a, 0, and a y-intercept at 0, comma b, and it wants to know what is the value of b over a. All right, they want no solution to the given system. What I'm going to do first is take this guy and solve him for y. In order to do that, I'm going to add 6y to both sides. That'll get me 16y plus 2 equals 4x. Now I subtract the 2 and divide each thing by 16. And now I've solved it for y. Now with the other guy, it's very simple to solve him for y. You just need to divide everything by t. So that would get you a 2x over t. But it would also get you a 1/2 over t. But now, if we want the system to have no solution, well, that can happen if the two equations are parallel, but they don't have the same y-intercept. So how do we get them to be parallel? Well, we would need their slopes to be the same. So we would need 4 over 16 to equal 2 over t. And that will happen if t is 8. So no solution problems can be done by getting the same slope and different y-intercepts. Now if I use t equals 8, the y-intercept here is not going to be equal to this negative number. So I'm good on that front. I can just walk away and say that the answer here is 8. All right. We got ourselves a isosceles right triangle, which means that the two legs are supposed to look basically equal, and the hypotenuse in this case is 58. And they want to know the perimeter of this triangle. But we can go to the reference sheet and we can see that one of the special right triangles, that formula is given to us. And the way that works is whatever the hypotenuse is, you set it equal to s radical 2. And then the other sides, we call them s. And if I'm going to want the perimeter, I'm going to need to know those sides so I can add them to the 58. But if I notice s radical 2 equals 58, that's an equation I can solve. So I go 58 equals s radical 2. The radical 2 being right next to it means that there's some multiplying going on. How do you cancel out multiplying? You divide. So that means I divide both sides by radical 2. And that means 58 divided by radical 2. And some of y'all might have seen that whenever you see a radical in the bottom, you can always multiply it by itself. And that turns it into the non-radical, leaving you with that radical up top. But now I gotta realize that I'm gonna have 2 of those sides. So whatever this comes out to, well, I gotta multiply it by 2, which means that the 2's will cancel. And it means that these 2 sides would add up to 58 radical 2. And then when I add that to the original 58, I say, oh my God, the answer was C. That's it. That's all you do. Take care. Welcome to problem number 19. They are asking us for a value of a minus b. I see the a over here. I see the b over here. And that actually looks like mx plus b. And they're giving me a table for f of x. And I can figure out what the m is. In other words, in this case, a. So that means a will equal the rise over the run. And I can choose any 2 points that I want to calculate the rise over run. And the way that will work is 64 minus 0 over 3 minus 2, which is 64 over 1, which is 64. So therefore, a equals 64. Okay, so I'm going to start off by putting 64 minus. Now I need to figure out the b. Well, b is the y-intercept. And if you ever want to get y-intercept, you want your x to equal 0. Now I don't see what's going on when x is 0, but I could easily figure it out because it looks like things are just going down by whatever the slope is, in this case 64. So if I go down by 64 one more time, that would bring me to negative 128. So that negative 128, that is our B. So we have to do A minus a negative, which is the same thing as A plus the positive. So 64 plus 128, and that can only be answer choice D. This SAT is actually kind of fun because it's getting harder and harder. We are on the third last question. Here it is asking us, what is the value of the largest integer from data set A? And if we look carefully, it says data set A consists of 10 integers, but then it says the list shown gives 9 of those integers from data set A. So they're not giving you the 10th one. So let's call that 10th one X. I don't know what it is yet. If I know what X is, then I'll be able to tell you what the largest one is. Well, they're telling us that the mean of data set A is an integer that is greater than 42. So maybe it's going to be 43. Maybe that's going to equal the mean. Okay, but a mean is equal to a sum divided by the number of numbers that you summed. So in this case, it would end up being 10. So that means the sum over 10 has to equal 43. Well, okay, but now what I can do is say that it's really the sum of the first 10. But if I wanted to get the sum of the first 10, I could do that by first finding the sum of the first 9 and then adding on that last number, which let's call that X. So how could I find the sum of the first number? The sum of the first 9. Well, if I know the formula for mean is that it's supposed to be the sum over how many numbers you added up, well, if I'm using 9 numbers, then if I wanted to get the sum, I would just have to do 9 times whatever the mean is. But, lucky for us, they told us what the mean is for the first 9. They told us it's 42. So that means I can do 9 times 42 to just get that sum real quickly. Now, of course, you could have also gone to your calculator and just typed in the sum of all those, but for those who are not aware of this, you would be able to get the answer faster with this nice little shortcut, where all you have to do is take the mean and multiply by the number of numbers. So in this case, 9 times 42, and that happens to come out to 378. So now it's 378 plus that extra number divided by 10 equals the 43. So now I just have to solve this for X. So multiply by 10, that'll get me 430 equals 378 plus X. And then I want to subtract. So let's see, 430 minus 378, that gets you 52. So it looks like X could be 52. And at the beginning, they told us that the 10 integers have to be less than 60. Okay, so 52 is less than 60, so far so good. But what were they asking for? What is the value of the largest integer? Well, now that we know X could be 52, it looks like the answer is just 52 then, right? But we didn't talk about what would happen if we had chose the number that was even greater than 43. Now, 43 is greater than 42, but they just said it has to be greater than 42, so maybe it could have been 44. But if you ran through the math, you would end up getting a number that's greater than 60, but you really didn't even need to do that because there's no answer choices here. So there must be only one answer. So once you get an answer that makes sense, that's it. That's your answer. You don't need to also run through the math again and try to see if there's another answer. No, you're done. You're just going to go with 52. Just to be super clear, the answer here is 52. All right, second last question here. For groups of 25 or more people, a museum charges $21 per person for the first 25 people, but then they charge $14 for each additional person. Well, which function gives the total charge in dollars for a tour group with n people where n is greater than or equal to 25? So let's pretend that there were maybe 27 people that went. Well, then in that case, what would I end up paying? I would end up paying 21 per person for those first 25 people. So F, which is the amount I'm going to get charged, would equal 21 times 25 plus the $14 for each additional person. So that's going to be 14 times, well, how many additional people? If there was 27, then that means there would be 2 extra people. Okay, but I just pulled a number out of my butt. So how could I have done this without having to, do what I did? Well, what I can do is I can say to myself, this 2, I could have gotten that by just doing 27 minus 25. And in fact, that's kind of how I got the 2, right? I said I got to subtract the first 25 people that I already paid for from the total number of people. But again, 27 was just the number I came up with. And it was just a random replacement for n. So really it should have been n minus 25. And now that we've done that, we know that it's really going to be 14 times n minus 25 plus whatever 21 times 25 is, which happens to be 525. So this should be what F is. Now, if I distribute here, I get 14n minus whatever 14 times 25 is, which is 350. And plus 525. So now 525 minus 350, what does that get us? What is that, 175? So that means I get 175 plus 14 and we are out of here. Other ways to do this problem, I could have continued with actually calculating what this was, but this is the fastest way to do it in case you are an SAT badass. If you're not interested in being an SAT badass, that's okay. That's fine. You can be a SAT mediocre person, but you're going to run out of time. So I do suggest that you watch this one more time in case you weren't able to follow all that. Leave a comment if it's still not understandable. Thank you. We got ourselves a similar triangle problem. So the first thing we're going to need is a triangle. But because the 2 triangles are supposed to be similar, let's make another one that has the same shape but is just a little bit bigger. That is what similar triangles mean. Okay, so now they're telling us LMN and RST, they're the 2 triangles. And one of the key details when I'm trying to label this is L and R each have to have a measure of 60. So let this one be L, this one be R, and say that both of those are 60. Now L and R, they correspond to one another. They're both at the beginning of this. And then we got M and S. So I'm just going to put M and S like so. And then N and T, so N and T. Now, what else did they give us? They told us that Ln is 10, so I'll put a 10 down here, and that RT is 30, so I'll put a 30 right there. Okay, So now they want to know which additional piece of information we would need in order to prove that these two triangles are similar. Now, one way to prove triangles are similar is by getting two pairs of angles. And we already do have one pair of angles. That would be L and R. So at that point, I could try to pick up another pair of angles. So it looks like they are telling me I could have M is 70 and S is 60. But wait a second, if this one was 70 and this one was 60, well, those angles are not equal. And if I have similar triangles, I have to have another pair of equal angles. So this one is actually definitely not the answer because these are not equal. Well, if I were to look at M being 70, then let's still keep this one as 70 up here. And T being 50, well, then let's put a 50 down here. Well, M and T, those are not the matching ones. But if I know that this one is 70 and this one is 60, then I could add those two up. That would get me 130. And then I subtract that from 180, and that would tell me that this one would have to be 50, which would actually get me that angle N is the same as angle T. So that gets me my second angle pair, and that's it. Turns out that's the answer. I don't even need to look at A and B and deal with some of the more complicated similarity facts. We can just deal with our good old buddy angle pair, also just called angle. And that's it. That wraps up practice test 1. If you stuck around for this whole thing, you must be a big nerd, or maybe you care about your financial future, or maybe you just like this stuff, and that's cool because honestly, I started to like it more too as I got older. If you need more help, go to boringmathtutor.com. Hit me up. I'll be here, and leave a comment. If you don't feel like reaching out to me, like, by calling me or anything, because, just some guy on the internet, right? Okay, but yes, whatever you want to do to make your SAT journey that much more efficient, that much closer to an 800. If you want to get to an 800, it's easier than ever now. But that's it. I'm going to shut up. I am going to say take care. Bye-bye.